I want to now talk about oblique asymptotes. In class, we've talked about horizontal and vertical asymptotes, but there's actually one more kind of asymptote. I did not have time in class to go over it very well. So let's talk about it now, and we can do a problem. So let me take a few minutes and try and give the background to what an oblique asymptote is. This has to do with, as we're looking at our horizontal asymptotes, asymptotes. And we looked at the whole key is you have to reduce the numerator and denominator to what we call the leading terms. In other words, you just keep the two terms with the largest exponent on the variable and throw everything else away, and then you compare those two leading terms. And we found out there's three possibilities. First, if the exponent on the variable in the numerator is less than the denominator. So just as an example, you could have something like this: 2x squared minus x plus 4 over 3x cubed plus x minus 1. By the time we toss out everything but the leading terms, basically all we're doing is comparing 2x squared over 3x cubed. And if we look at the variables, they furthermore cancel down to basically 1 over x. And basically, when x gets to be very large, f of x will approach 0. So therefore, for this one, the horizontal asymptote is y equals 0. And we talked about this in class. Whenever the numerator is less than the denominator, the asymptote is y equals 0. And then we talked about what happens when the numerator is the same as the denominator. So as another quick example, we talked about 2x squared minus x plus 4 over x squared plus 3x plus 15. Once again, if you reduce it to leading terms, 2x squared over x squared. Turns out in this case, the numerator and denominator are equal in terms of the variable and the exponent. So this simply reduces down to 2. And in this case, we'd have a horizontal asymptote of y equals 2. And then the final case was where we said the numerator ended up being larger than the denominator. So here's the example I want to look at. How about this one? F of x equals x squared minus 9 over 2x minus 4. If you get rid of the leading terms, this sort of reduces down to x squared over 2x, where it reduces down to just basically x. And we said in this case, there's actually no horizontal asymptote, because as x gets large, f of x gets large. And that's the case. But now we have one special situation under the category when the numerator is greater than the denominator. And that's if the numerator is only greater by 1. So basically, another way to think about that is to say, here's one way I thought about it. if you take the exponent on the variable in the numerator and subtract the exponent on the variable in the denominator, it equals 1. In other words, the numerator exponent is 1 larger than the denominator. So there's still no horizontal asymptote, but in this case, we do have this thing called an oblique asymptote. So let me just go ahead and work out this problem right here, and then you'll see what the oblique asymptote is. So let me just start a new page, and we'll treat this as just a normal kind of problem where we're going to find intercepts, and we're going to find asymptotes, their irony, and sign charts, and all those kinds of things. So f of x or y equals x squared minus 9 over 2x minus 4. Let's go and factor. The numerator is the difference of squares. And the denominator I can factor out of 2. All right, so now let's look at intercepts. How about y-intercept? If I set x equal to 0, I'll use this first form. Looks like y-intercept is going to be 9/4. Or I could write it as 0, 9/4, which is like 2 1/4. The x-intercept is when I set y equal to 0. So here would be my, actually let's use the factored form for this one. Now if I multiply both sides by the denominator, I'm going to end up with 0 equals x plus 3, x minus 3. So it turns out I have two x-intercepts, -3, 0, and 3, 0. Now let's look at asymptotes. First, vertical asymptotes. We just look at the denominator and decide what value of x would cause the denominator to be 0. Looks like x equals 2 would be a vertical asymptote. Now the horizontal asymptote, when I compare leading terms, I'll have x squared over 2x, which reduces down to x over 2, which means there is no horizontal asymptote. However, since the numerator is just 1 greater than the denominator, I'm going to have an oblique asymptote. So here's how we calculate the oblique asymptote. We perform what I call old-fashioned division. I take my original problem, x squared minus 9 over 2x minus 4, and I write that out as old-fashioned division, and I'm actually going to perform sort of like old-fashioned division. Hopefully I'll remember how to do this. I've got to put my x term in here, so I call it 0x. So now, I look up here, what times 2x would equal x squared? 1/x. 1/x times 2x is x squared. 1/x times -4 is -2x. I subtract this, just like we used to do old-fashioned division. I get 0 here, and here I get 0x minus the -2x, which looks like 2x. Bring down the -9. What times 2x equals 2x? 1. So now 1 times 2x minus 4, and I subtract, and I'm left with -5 as my remainder. So in a sense, what I've done is I said that x squared minus 9 over 2x minus 4 would equal 2x minus 4, and then the remainder minus 5 over, whoops, not 2x minus 4, sorry, 1/2 x plus 1. And then the remainder is 5 over 2x minus 4. Now the thing that happens, if you look at this little equation here, as x gets to be really large, this last term basically goes to 0 because the x gets large, and you're just left with 1/2 x plus 1. And as it turns out, if you look on a graph, 1/2 x plus 1 is a linear equation. That's just going to be a line on the graph. So here's what I'm going to do. I'm now going to go ahead and let me go ahead and do the sign chart, and then we're going to graph this, and you'll see when we get to it how I'm going to graph this oblique asymptote. So let's go and do my sign chart. So once again, let me write this up here. My factored equation. And of course my sign chart, my boundaries are going to be my x-intercepts and vertical asymptotes. I have an x-intercept of minus 3, an x-intercept of 3, and a vertical asymptote of 2. So it looks like I'll have 4 regions. So let's go ahead and do my sign chart. Region, test point, then I have 3 factors, and then overall. So region 1, 2, 3, 4, test point for region 1 minus 4, test point for region 2. I'll just go 0. For region 3, got to pick like 2.5. And region 4, I'll choose 4. And now my sign chart, negative, 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 overall negative. Region 1 is negative. Region 2, positive, negative, negative. Region 2 is positive. Region 3, positive, negative, positive. Looks like region 3 is negative, and region 4, positive, 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 positive. All right, so let's take all the information that we've got so far, and let's try and create a graph, and let's see what happens. So what have I got? I have a y-intercept of 9/4, which is like 2 1/4, so it's somewhere right in here maybe. I have 2 x-intercepts, negative 3, 0, and 3, 0. I have a vertical asymptote at x equals 2. And then I have this vertical, well, let's put in my sign chart stuff. So from negative 3 to negative 4, this region is going to be negative. Then from negative 3 to 2, it's positive. And then from 2 to 3, it's negative, right in here. And then from 3 on, it's positive again. Now let's go ahead and draw in this oblique asymptote. So if you remember, I said my oblique asymptote is going to be this linear equation right here. I'm actually going to go on this graph, and I'm going to graph this line, and I'm going to make it a dashed line, because it is an asymptote. So if I was going to graph this, of course, my y-intercept is 1, and then my slope is 1/2. So I'd go up 1 over 2, and now basically I have an oblique asymptote, which is like an asymptote, except it's not vertical or horizontal, it's like at an angle. So now, let's try and figure out what's going on with this graph. And you can always plot some points, but I think what's going to happen is, I believe the graph is going to look like this. I've got these 2 points right here. So my guess is it's probably going to look something like this. And over here, what's interesting is, it goes through here. And you notice over here, I do have an asymptote. My graph actually tracks and gets very close to this oblique asymptote but never touches it. So that's the idea of an oblique asymptote. Both on the left-hand side and the right-hand side, my graph begins to track this oblique asymptote. So I think you have a problem in the homework with an oblique asymptote. So that's the idea.